Okay, so recall. First of all, the definition of log. X is equal to log to the base a of b is nothing but we find the value of x so that a raised to x will become b. Okay, so this is the basic definition by which a lot of examples in your additional exam could have been solved. First one. Second, there are two types of logs, log to the base e and log to the base 10. One is the natural log and the other is common log. So common log logarithms to the base 10, this is called the common, and this is log to the base e is called the natural log, because while doing the calculation this is the naturally occurring log. Third one that we have seen are the properties of the logarithms, the small theorems. So the theorems log to the base a of m into n is nothing but log to the base a of m plus log to the base a of n. So logarithm says that you add, if there is a product, log to the base a of m by n is equal to log to the base a of m minus log to the base a of n. Fifth one, log to the base a of m raised to n. This is equal to n log to the base a of m. Sixth one, this is the change of base formula which says that log to the base a of n is nothing but log to the base e of n upon log the base e of a. So this is called the change of base formula. Change of base formula. There was an MCQ which asked log e to the power log to the base e of x, or simply e to the power log to the base a of x. Let's make it e as it is. So this is going to be x, because how can I write this? This will be e log to the base e of x. This is actually equal to x. Fine. Then we have seen how to take the logarithms of certain number. So when I take log to the base 10 of any number capital N, that is nothing but characteristic plus mantissa. So first of all, we will revise how do you find out characteristic for certain numbers. If n is greater than 1, then number of digits before decimal point, before decimal minus 1. If n is between 0 and 1, so if 0 is less than n is less than 1, so if a number is between 0 and 1, then number of digits, number of zeros after decimal point, zeros after decimal point decimal point plus 1 plus 1 with negative sign, with negative sign. Okay, this is how we find out the characteristic. And then about the mantissa. Mantissa we get using the log table. Mantissa using log table. Log table. In the log table, what we have to do is we need to just need to look at the, if there are four terms, you look at the first four terms, 1, 2, 3, 4 for an example. You look at the row 1, 2, and you look at the column 3. So there will be some number there, and there are small columns at the most right hand side of the log table, and in that we will look at 4. Whatever the corresponding entry we have, we will add it to this, and it is our mantissa. Okay, so this is how we find the mantissa. Before that, there are some messages popping up on WhatsApp that you're not able to join. So you can put a message on your unofficial group that join immediately, so that I can wait for a while. Fine. So once we are done with this, take a screenshot of it. This is compiled information of all the logarithms. Fine. After this, we'll solve some of the example. One or two, I guess we have solved. But still, this wherever you have to use the properties of log. Look, what is going to be very much important in your uh, career or whatever things you will be doing in your other subjects are these properties. What do you mean by log, first of all, and these properties? So wherever you will be proving or doing something, these properties are going to help you a lot, because these are generally used to simplify different equations. Whereas this is to calculate, I mean, but scientific calculator is now actually allowed. So this much things you won't be doing it every time unless and until your calculators are not allowed in exam. But I guess those are allowed. So this may not be used a lot of times, but these properties are something that should be used, and that should be something that you keep it in your with you whenever or wherever required. Fine. So example, prove that log of x by y plus log of y by z plus log of z by x is equal to 0. So log of x by y plus log of y by z plus log of z by x. This is your LHS. So which property can be used in the first one? Log of a by b is equal to log of a minus log of b. So by that, what we have is log x minus log y plus log y minus log of z plus log of z minus log of x. So this minus plus minus plus. All these things get cancelled out and the answer is 0. Simple. Next, log to the base a of x into log to the base b of y is equal to log to the base b of x into log to the base a of y. This is show that. Can someone try? Take LHS and get to the RHS. Aman, tell me. No one can try this.
So may I?
Yes,
So it will be like log x base e upon log a base e multiply by log y base e upon log uh, b base e and will equals to that only. And
log.
we will going to both side.
Yes. So what we have to do is we have to adjust the terms. As I need log to the base b of x, take this on this side and the one on the other side. Log to the base e of x, very good. E of b into log to the base e of y upon log to the base e of a. Again, by change of base formula applied here, what is the change of base formula? Log to the base a of b is equal to log to the base e of b upon log to the base e of a. So using this formula, here what you get is log to the base b of x into log to the base a of y. This is the one and the same thing that is on the RHS. Fine. Third, if log of a plus b by 2 is equal to 1 by 2 log a plus log b. Show that a is equal to b. So consider the given equation. If anyone has any idea, you are free to talk about it, or else I'm going to do it. 1 by 2 log A plus log B. This is given to us. Somehow I need to show that A is equal to B. Okay, so what we do is we use the properties. First of all, log A plus log B. What it is? A plus B by 2. This is equal to 1 by 2 log of A into B. Right? Now we have another property. So I'll state the properties here. Log of A plus log of B is equal to log of A into B. The first property that I have used. Later, log A plus log B is log of M log N is equal to log of N raised to M. So this is 1 by 2 log of AB. So this can be written as A plus B by 2 is equal to log of A into B raised to 1 by 2. Anyone, what do you mean by AB raised to 1 by 2? X raised to 1 by 2 is nothing but
root x.
root x. So log of A plus B by 2 is equal to log of under root AB. Now these logs will cancel out each other. So what we have, A plus B is equal to under root of AB. So I need to show that A is equal to B. So I will square both the sides. Squaring both sides. So what do we get? A plus B square by 4. A plus B whole square by 4 is equal to under root AB square. So that will be simply AB. So A plus B square is equal to 4AB. Now I can square this. A plus B square is A square plus 2AB plus B square is equal to 4AB. Now taking this 4AB on the other side, what we have, A square minus 2AB plus B square equal to 0. Right? What is A square minus 2AB plus B square?
A minus B whole square.
So that is A minus B whole square equal to 0, which means that A minus B is equal to 0. So A minus B is 0, it means that A has to be equal to fine. Next, if A square plus B square is equal to 7AB, then show that log of A plus B by 3 is equal to 1 by 2 log of A plus log of B. Look, one thing you have to be very much clear here about what is to be shown. So on the left hand side, what we can see is log of a plus b by 3. If I take this 1 by 2 on the other side, that will be a plus b square by 9. And log of a plus log of b is actually log of a into b. So what I'm supposed to do is I need to make this a plus b square, okay, so that this 1 by 2 will come in picture. So consider. So whenever I have to reach somewhere, you will have to decide, I mean, what road you should be choosing. So from this, I am able to observe that a plus b square has to be there if I take this 2 on the other side. So what I will do is I'll add 2ab on both sides. A square plus 2ab plus b square, and 7ab plus 2ab will become 9ab. So adding 2ab, adding 2ab on both sides. So once I add 2ab, so this is what I have got. Now a square plus 2ab plus b square is a plus b whole square, which is equal to 3 square ab. So this is a plus b by 3 whole square is equal to ab. Now taking log on both sides. So what we have, log of a plus b by 3 whole square is equal to log of a into b. But from this, a plus b by 3 square. So I will use log of m raised to n property. By that, this 2 will come here, log of a plus b by 3, which is equal to. Now log of a into b is nothing but log of a plus log of b. Now take this 2 on the other side, log of a plus b by 3 is equal to 1 by 2 log of a plus log of b. Yeah. Wherever you have any difficulty, you can uh, simply ask me, because I can understand your from biology background, so you may have silly problems somewhere. So I'll be happy to address those difficulties. Next example, if a square plus b square is equal to c square, then show that 1 upon log to the base c plus b of a plus 1 upon log of c minus b of a is equal to 2. Look, initially it will look very much difficult. Okay, I may not know what I have to do, but from the show that you can take LHS and you can use the change of base formula. What you are going to get, you will get log of c plus b upon log a plus log of c minus b upon log a. Denominator is same, So what we have, log of c plus b plus log of c minus b, totally divided by log of a. Then this log of a plus log of b property I will use here. That will be log of c plus b into c minus b upon log of a. What is this? C plus b into c minus b.
C square
C
minus B
square
square.
minus B square.
So that is c square minus b square upon log of a. So from where I will have to start in this case? I will have to take this b on the other side so that I have c square minus b square. Then I will take log. Okay. So this is how you can start up with showing that examples. You look at where I have to reach, you do some calculations so that you understand how I have to reach over there. Okay. So I'll rub this since I have observed from where I have to start. So consider b square, oh sorry, a square is equal to c square minus b square. Now taking log on both sides. So log of a square is equal to log of c square minus b square. So log of a square is nothing but 2 log of a, and on the other side this is log of c square minus b square is c plus b, c minus b. Again this is 2 log a equal to log of a into b. So that is log of c plus b plus log of c minus b. Then I will take this log a on the other side. So 2 is equal to c plus b upon log of a plus log of c minus b upon log of a. So I need that thing in the denominator. So 2 is equal to 1 upon log a upon log of c plus b plus,
So,
yes,
so can we directly in c plus b, c minus b, we can directly write log c square minus b square.
just understood. Can you repeat?
Sir, in 2 log a is equal to log c plus b into c minus b, can we directly write log c square minus b square?
But I have to go from c square minus b square to c plus b, c minus b. Are you getting my point? You're saying that here itself you want to write down c plus b, c minus b.
Yes, sir, like c square
Yes, you can.
minus b square, we can directly write a, right? A square.
No. If you put a square over there, you won't get the required expression. A log a will get
Okay, sir.
cancelled out. Say for an example here, if I put log of a square is equal to log of c square minus b square is nothing but a square. This both are getting cancelled out. You won't get anywhere from this. Okay. So I have to proceed
Okay,
in a
sir.
manner that I should get this expression. Now, so this is equal to 1 upon, by change of base formula, this will be log of a to the base c plus b plus 1 upon log a to the base c minus b. is the required expression.
So may I ask something?
Yes.
Sir, how that log c plus b gone into denominator?
Uh, there is a small property which says that a by b is 1 upon b by a, right?
Yeah,
So,
yes, sir. Thank you.
reciprocal, when I say reciprocal, say x can be written as 1 upon 1 by x. Okay, so this comes from the property that you have studied in your ninth standard, which says that uh, a by b divided by c by d. So this I can write as a by b into d by c. This is a ninth standard property, which is of course hard to relate with this because there is a division on the left, which means that how I am writing this a by b upon c by d. So this is nothing but a by b into d by c. Now, when whatever I have in the numerator, that can be taken in the denominator by taking its reciprocal. Okay, that's all you have to understand. कि अगर कुछ न्यूमरेटर में है, so that will go in the denominator of denominator. Okay, fine. Fine. So those are all theory examples on logarithms. Just one last thing now that is remaining: how to find out the anti-logarithm. Okay. So before I start with anti-logarithm, I'll first of all take an example. Say for an example, I want to simplify a expression which is, for an example, 6 by 3. Okay, you can orally tell the answer, and that is 2 here. Okay, but to explain the method of log, how we find this, I'm going to take this example. So I want to find this, I don't know, but I know log. Okay, so say for an example it is x. I'll take log on both the sides. Log x is equal to log of 6 by 3. What is this? Log of 6 by 3 is log of 6 minus log of 3. We know how to take log of 6. How many digits are there before the decimal point? There's one digit, right? So the mantissa, characteristic for this is going to be, anyone? What will be the characteristic? How do we find out the characteristic if the number is greater than 1?
The characteristic will be 0.
0. Characteristic will be 0 because what is the rule? I'll write down the rule here. If the number is greater than 1, then number of digits before decimal before decimal minus 1, right? And if n is between 0 and 1, then number of digits, number of zeros after decimal after decimal plus 1 with negative sign, with negative sign. That is the idea. Now the digits before the decimal point is 1, so 1 minus 1, 0, point. Now what we have to do? We have to look in the log table. We'll have to look at 6, right? 6.0. So for 6.0, what is the value that we have? 7782. So our mantissa will be, so characteristic 0 plus 0.7782. Whoever have the log table, please look at this. So this is our characteristic. This is our mantissa, which we have found using log table. Then minus log 3, number of digits before the decimal point, that is just 1. So 1 minus 1, 0, plus. What is the mantissa for this? Look at 3.0 and the column 0. So that is 0.4771, right? Again, this is the characteristic and this is mantissa. Now what I have to do, 0.7782 minus 0.4771, and that is going to be 0.1. 8 minus 7, 1, 0, 7 minus 4, 3. So log of x is this, right? Now what I have to do is x will be equal to log of 0.3011. Okay, clear up to this? Now what you do is there is an anti-log table too. If you don't have it, let me know. I'll put a photo on your WhatsApp group so that you can refer the table. If you have it, well and good. Please raise your hand if you want the anti-log table or you have. I will put it on the group. If you want it, please raise your hand. So the two photos that I have put on your group, those are logarithm anti-log table. Third one is for log table. The fourth is also the log table. Okay, so when I want to find the anti-log of this, what you do is in the anti-log table, you can look at these 4 digits, 3011. Okay, so in the anti-log table, look at 0.30. Then you look at 1, the entry is 2000. Again, look at the last columns, there is 1, the entry corresponding to 1 is 0. So x is equal to 2000. Everyone got up to this?
Yes, sir.
Now, we have one thing to decide now, that is where to put that decimal point. So this characteristic that you have, characteristic decides position of decimal point. Okay, so whatever is your characteristic, that is going to define the position of decimal point. And I'll write down the rule here. Rule. The first rule is characteristic positive or 0. characteristic positive or 0. Put the decimal point after n plus 1 digit. Put decimal point after n plus 1 digits. The second rule is if characteristic is negative, characteristic is negative, then put decimal point in such a way, in such a way that it succeeds in minus 1 zeros. Okay. So come back to our example now. What is our characteristic here? That is 0. Okay. So if the characteristic is 0 or positive, put the decimal point after n plus 1 digit. What is n? N is the characteristic. What is our characteristic here? 0. 0 plus 1. So after one digit, I will have to put the decimal point. Right? So what we have, x is equal to 2. Clear? So once you have written this rule, please note this example. Then we will do for 3 by x. 3 by x, I know that the answer is 0.5, but still we will solve using logarithm. This is our example number 1, 2. Find 3 by 6 or 1 by 2 for an example. 1 by 2. So let x is equal to 1 by 2. I'll take log on both sides. Log x is equal to log of 1 minus log of 2. Log of 1, characteristic for this is 0 point. Now look at the mantissa from the log table. What we have to look at 1.0.000, right? So what do you get? 1.0 is 0.000 minus log 2. 0 is the characteristic for this dot. What is the mantissa? 2.0. Look at 2.0 and column 0. That is 3010. Fine. So what is the answer here? This is equal to minus 0.3010. So what we have got here, there is a problem. When I say minus of 0, it is minus 0 minus 0.3010. But whenever I am using anti-log, mantissa should never be negative. Okay, so you can write down the remark just beside this that mantissa cannot be negative. So I have to convert that mantissa to positive by adding and subtracting 1 there. Okay, so at this stage, caution. Mantissa cannot be negative. You have to convert it to positive. And how can I convert it? I'll subtract 1 minus 1 plus 1 minus 0.3010. So what we have got now? So this is equal to minus 1 plus in bracket. What will be the answer? 1 minus 0.3010. So that is 0.6990. Right? Now what we have x here is anti-log of 1 bar dot 6990. What does this bar mean? Bar means characteristic negative with mantissa positive. So now what I'm going to look at the things after decimal point. What are the things after decimal point? 6990. Now go to anti-log table, look at 0.69, 0.69 and the column number 9. What is 50000? So 5000. Now what is 1 bar? 1 bar is nothing but minus 1. Bar means characteristic is negative. What is the rule for negative? Put the decimal point in such a way that it exceeds n minus 1 0. What is the characteristic here? 1. 1 minus 1. Right? So 1 minus 1 is 0. So there is no 0 before the decimal point. So you just have to put that over here. So isn't the answer 0.5 of 1 by 2? Anyone having problem, please ask freely here. Because after this, we'll take some difficult example. So I will just sum up these two things in a remark and then we'll solve a difficult example. I hope you are done writing so that I'm rubbing this.
Wait, sir.
Yes. The remark 1. Bar on characteristic represents that characteristic is negative and mantissa is positive. Second, while finding antilog, convert negative mantissa to positive. Very important remarks over here. Should I go ahead? Someone stopped me. Are you done writing?
Oh, yes, sir.
Yes, sir.
Okay. So the example, simplify using table is under root 0.395 square 2.45 upon 8.034. Okay, so I'll call this x. X is equal to under root of 0.395 square 2.45 upon 8.034. Taking log, what do we get? Log of x is equal to. So log of this thing raised to 1 by 2 will be 1 by 2. Look, I am using one property immediately over here. This is 0.395 square into 2.45 divided by 8.034. Now again I can simplify this. These two are in product and there is one in division. So division will become minus in bracket. Log of 0.395 square plus log of 2.45 minus log of 8.034, right? Now again I can use a property over here, log of 0.395 square. So 1 by 2, 2 times log of 0.395 plus log of 2.45 minus log of 8.034. Look, these three steps, I mean, they can be done orally, right? These are not so much difficult. So that's why log table is useful to simplify or find out a lot of values without too much of manual calculation. So log of 0.395, this number is between 0 and 1. So the characteristic here is going to be yes, anyone? What is the characteristic here going to be? If the number is between 0 and 1, you look at the number of zeros after the decimal point plus 1. That will be the characteristic with negative sign. Am I right? So that is going to be -1 is the characteristic plus what is the mantissa for this? 395. Look at 3.9 and 5. What it is? 5966. So this is 5966. So 0 point. 0.5966 plus 2.45. There is one digit before the decimal point. So what we are going to do? -1. So if it you have a number greater than 1, then what we do is number of digits -1. That will be the characteristic 0 plus look at the mantissa for the second number 24, 2.4 and 5. 2.4 and 5. The number is 3892. 0.3892 plus minus. Look at the last one, log of 8.034. One digit before the decimal point, -10 plus what is the mantissa? 8.034. 8.0, look at the third column, 9047. And in the last small columns, we have to look at 4. The value is 2. So add it into this 9049. 9049. What we have to do? Anyone? What can we do of the first term? What for the first term? Characteristic is negative. Mantissa is positive. So that will be -2 plus multiply 2 to the 0.5966. That is into 2 is 1.1932 plus 0.3892 minus 0.9049. You can do this addition subtraction here. So that is 1 by 2 in bracket -2. So 1.1932 plus 0.3892 minus 0.9049. So that is plus 1.5334. Again, you can do the subtraction. So that is 1 by 2 in bracket -2 plus 1.5334, which is minus 0.4666. Again, you can divide this by 2. So which is minus 0.2333. This is log of x. Now, what is the problem here on the right hand side? Again, you have characteristic negative as well as mantissa negative. This is actually minus 0.2344. So what I have to do is Before I take anti-log, I will have to convert it to positive. So I'll rub the starting part. So I will add 1 and subtract 1 there. So x is equal to anti-log of, so minus 1 plus 1 minus 0.2333. So this is anti-log of 1 bar dot. What is the answer? If you subtract 0.2333 from 1, it is 0.7667. Now 1 bar is there. Okay, leave it. Leave this part. Look at the anti-log table, 7667.76. Then look at the column 6, 5834, and look at the last column 7, it is 9. So 5814 plus 9. 14 plus 9. 5823. Right? So we can write down the term 5823. This is equal to 5823. Now what I have to do, I have to look at the characteristic. Characteristic it is negative and that is minus 1. What does the negative characteristic represent? Then the decimal point is placed in such a way that it exceeds n minus 1 zeros. What's the value of n here? 1. 1 minus 1 0. So that will be no 0 before the decimal point. So the answer is 0.5823. Any problem?
Sir, will you explain me that third last line?
What do you mean by third last line?
Sir, half in bracket minus 2 plus 1.1932 plus
Huh,
0.3892 minus 0.9049.
huh.
सर इसमें सर लाइक -2 को अच्छा ओके मल्टीप्लाई किया क्या -2 इंटू 0.5966 को
What you're asking, I didn't understood. I mean, first of all, you narrated this line, this one.
यस सर
Huh. So now,
नो नो आई गॉट इट दैट एक्चुअली वो मैंने मल्टीप्लाई नहीं किया था 2 को मेरा आंसर नहीं आ रहा था इसलिए
okay, fine. So you can try one using table. Simplify, simplify using table. 1 upon cube root of 0.341. So you can try this. So this is the end of our logarithm. What we will start in the next lecture is the most important chapter of your syllabus, which will take almost a month to complete minimum. And so I'll suggest that don't miss the lectures after this. Even if you have missed before this, I mean, that won't matter much now. But if you miss the lecture after this, it will pay you a lot. Okay, so please don't miss the lectures after this. Try this example. If you have any difficulties, you can ask in the next lecture. Today we'll stop here. Everyone can put your name and in the chat box. Roll number if you have the roll number. If not, then simply put your name. Yes, Udit, any problem?
No, sir, no.